Well, here we are on the 15th day of December. This will be our last Tuesday together in 2020, won't it? Unless anybody wants to come in next week, I'll meet you here if you need to. We'll go over notes and do some geometry problems. Anybody want to sign up for that? No? Okay. Today we're going to work with special segments in a circle. These are special segments in a circle. Anybody going on a good vacation over the holiday break? Where are you going? You're going to Christmas? Christmas, Florida? Nice. You're going to Christmas for Christmas? Oh, okay, I get it. You know that there's a Christmas, Florida? Yeah, it's up near Titusville. So that would be interesting if you were going to Christmas for Christmas. Get it? Good. Well, maybe that day you could ask your mommy or daddy if they could drive you to Christmas. Drive up there, maybe have breakfast and drive back. And that way, after the break, if anybody asked you, what did you do over the break? You could say, I went to Christmas for Christmas. Right? Wouldn't that be awesome? I might do that. Christmas Day, I might drive to Christmas. Okay. If two chords intersect in a circle, then the products of the lengths of the chord segments are equal. So draw a picture of a circle with two intersecting chords. If we label this, we got A, B, C, D, and E. What the theorem says, got two chords intersecting inside a circle, so they're intersecting at point B. The products of the lengths of the segments are equal. They're saying that AB times BC. What's AB times BC going to be equal to? DB times BE. Very good. Now, what it looks like they're doing is they're exposing you to some stuff from Algebra 1 that you haven't seen in a while. So let's say we got an x plus 12 right here, and then b to c is equal to x. And then D to B is equal to x plus 6. And B to E is equal to x plus 2. So it's been a while since you've done this. So here's your setup. A to B is x plus 12. And B to C is x. And that's equal to x plus 6 times x plus 2. All right, so on the left, you've got a binomial times x, and on the right, you have two binomials. So you got a lot of distributive property to do right here. You got to multiply the x, these two x's, so you get an x squared, and then the 12 times the x, that's a positive 12x. And now on this right-hand side, I don't know what you guys were taught when you took Algebra 1, if you were taught the FOIL method, which is, first, outside, inside, last, distributive property. But here's how you multiply two binomials. You multiply the x times the x, and you get an x squared. And then you multiply the x times the 2, and you get a positive 2x. Then you multiply this 6 by the x, and you get a positive 6x. And you multiply the 6 times the 2, and you get a positive 12. All right, and then you got to combine these two terms in the middle. So your positive 2x and your positive 6x, this becomes plus 8x. All right, all this in the middle becomes positive 8x. Okay, so now you got to solve for x. So you're going to subtract x squared from each side. And we're going to get 12x equals this 8x plus 12. And now you can subtract 8x from each side. So 4x is equal to 12. And then you can divide both sides by 4. So x is equal to 12 divided by 4. That's a 3. So whether they're asking for the value of x or if they're asking for all those segment lengths, you need to find the value of x, and then you could substitute to find each individual length. Everybody okay with that? Kind of a key things right here was this, distributing this x to the x and the 12, and then multiplying these two binomials. All right, this is simple work, but some of you guys that don't like to show your work and you like to do a bunch of stuff in your head seem to make mistakes on these tedious step problems. So I would just recommend that you slow down a little bit and go ahead and show your work and do the individual steps so that you don't make a careless mistake. Okay? Anybody need to see another example of two chords intersecting inside of a circle? Two chords intersect inside of a circle. The products of the segments are equal. The products of the segments are equal. All right. Next theorem is a little wordy. If two secants intersect outside of a circle. Then the product of one secant segment actually let's do this. Replace this word one with the. Then the product of the secant segment and its external segment is equal to the measures of the other secant and its external segment. The picture is way easier to understand. So let's, two secants that intersect outside of a circle. So here's what that would look like. Remember what a secant is. It intersects a circle in two places. So it could do this, or it could do this. It could either keep going all the way through the circle, or it could stop on the circle. It's still, both of these still intersect the circle in two places. So label this A, B, and C. And label the other 2 points of intersection D and E. Here's what the theorem says. It says that AC times AB, AC times AB is equal to AE times AD. And I call this the whole piece times the outside piece. All right? A to D, here's your whole piece. Sorry, A to C. A to C, there's your whole piece. Times the outside piece right here. Whole piece times outside piece. equals whole piece times outside piece. That's the way I was able to remember it. The whole piece times the outside equals the whole piece times the outside. So if we add some values to this, let's go with a x and an 8. All right, so if this piece is x and this piece is 8, and then down here on the bottom we got a 10 and a 6. 10 on the inside, 6 on the outside. All right, so this whole piece right here, we're going from A to C. That's going to be x plus 8. All right, so we got A to C, which is x plus 8, times the outside piece, which is just 8, is equal to, now the whole piece on the bottom, the whole secant. That's all the way from A to E, so that's 16. And the outside piece there is A to D, and that is 6. So you've got more distributive property to do here. So you got your x times your 8, which is 8x. And then you have your 8 times your 8, and that's a positive 64. And that's equal to your 16 times 6, which is 96. So you can subtract 64 from each side. And your 8x is equal to 96 minus 64 is 32. And then we can divide both sides by 8. And x is equal to 4. Good morning. All right, and again, a point of emphasis would be this, entire secant length or the whole piece. When you get it broken up like this, make sure that you remember to make it x plus 8 and not x times 8 or 8 times x. You already went?
Yeah.
Okay. That was short and sweet, huh? Okay. You can just wait till I'm done if you want, and I'm going to upload it. I've only got one more theorem to go over. Any questions, or anybody need to see another example there? 2 secants intersecting outside of a circle. Okay. One more rule. If a tangent and a secant intersect outside of a circle, if a tangent and a secant intersect outside a circle, Then the square of the tangent is equal to the product of the secant, and we're going to say the product of the whole secant and its external segment. This is the last rule I've got to cover, and then I'll upload it to YouTube if you just want to wait a little bit and get it done. Hello.
Hey, I need help.
With?
My DocuCam, because it's different than what I normally use.
I don't have one, but I'm just about done. I'll come over as soon as I'm done.
Okay.
Thank you. All right, so let's take a look at this here. Sir. We got to work on that circle. Circle. So remember what a tangent hits a circle in exactly one place. So here's our tangent and a secant. Tangent and a secant that intersect outside of a circle. Here's what the rule says. It says that AB, the entire segment AB squared, is equal to AD times AC. All right, so very similar to the last rule, you got tangent squared equals whole piece times outside piece. All right, tangent squared equals the whole piece times the outside piece. Now it looks like let's do one of these examples here where we've got the tangents equal to 8. We got this C to D is equal to 7. And we got A to C is equal to X. So if we take our AB squared, we get 8 squared is equal to the entire piece, which is what? What's the entire piece here? Good. I like X plus 7, but. And times the outside piece, which is X. So now we got 64 is equal to X squared plus 7X. All right, so now you got some issues that you haven't seen in a while because you've got an X and an X squared in the problem. So what you got to do here first is you got to subtract 64 from each side. And we get 0 equals X squared plus 7X minus 64. All right, and again, you did that in Algebra 1 when you were solving for x in a trinomial, quadratic. You got an x squared and you got an x in this problem. One of the ways that you could solve for x in a trinomial like this would be to factor it and set both factors equal to 0. But since this trinomial is not factorable, what I mean by factor it, you need two numbers that multiply to 64 but add up to 7. All right, and there aren't any. There's not, that combination of factors doesn't exist because the factors of 64, all right, you got 1 and 64, you got 2 and 32, 3 doesn't go into 64, 4 goes into 64 16 times, 5 doesn't go, 6 doesn't go, 7 doesn't go, and 8 times 8 is 64. Those are the numbers you can multiply together to get a 64. But you have to be able to add them together to get a 7. And you can't do that. None of these combinations allow you to do that. The 8 and the 8, they give you, if you messed with their signs, they would give you a 0 and a 16. The 4 and the 16, if you messed with their signs, would give you a 12 and a 20. The 2 and 32 give you a 30 or a 34. None of those work to get this 7. So what you get to do is the quadratic formula. All right? And the quadratic formula, you did it last year. The quadratic formula says that x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. And I don't know if y'all went to Johnson or not last year, but in the past, these kids have come over here and they like sing this thing. Yeah. So you know the quadratic formula because you know the song, and I know you've done it, right? So unfortunately, there's just a few steps involved, but it's not that bad. Now, remember over here, what's in front of the x is your a. In front of the x squared is your a. In front of the x is your b. And to the right of the x is your c. When everything's on the right or one side of the equal sign with exponents in descending order, all equal to 0. All right, so what I like to do is have people list the a, which is 1, then the b, which is 7, and then the c, which is negative 64. And now you can just substitute, okay? And be careful again. So let's say we got x is equal to negative 7 plus or minus the square root of 7 squared minus 4 times a times c, all divided by 2 times 1. So we can clean this up a little bit now. That's negative 7 plus or minus the square root of 7 squared is 49 minus 4 times 1 times negative 64. That's negative 256. So all of this is minus a negative 256. We're still dividing by 2. So under this radical, we've got a 49 minus a negative. So that's going to be a keep, change, change. So we get negative 7 plus or minus the square root of 49 plus 256, which is 305 over 2. So now this problem, this x value, is going to have two answers. All right, in your calculator, you take negative 7 plus square root of 305, and you divide it by 2. You take negative 7 minus the square root of 305, and you divide it by 2. So you're going to get x equals two values here. So I'm going to do the square root of 305 first. I'm going to do it plus 7 negative, and I'm going to divide that by 2, and I'm going to get a 5.23, or I'm going to do 7 negative minus 305 square root equals, I'm going to divide that by 2. We get negative 12.23. So those are my two potential values for x. So if we go back and look at the problem, we see this x that's sitting right here, agreed? The x represents a distance, doesn't it? It represents the distance from A to C. Can we ever represent a distance with a negative value? No such thing as negative distance, is there? So we're not going to use the negative 12.23. We're only going to use this positive solution. All right? So in this case, our x is equal to 5.23. All right, so 3 new rules today. At the same time, though, you're using new techniques in solving for these variables. So a lot of new information. Lot of new information today. All right, so here's your practice for today. We're going 133 and 134. All problems.
I have 135 as special segment circle.
You don't have a 133 and a 134?
33 and 34 was yesterday, yeah.
33 and 34 was yesterday? Oh, my bad. It's 35 and 36, right? Sorry about that. 130. Page 135 and 136. All problems. All right. You guys that are in class, do them on a separate sheet of paper. You guys that are at home, do them on a separate sheet of paper too. There's not enough room to show your steps. And I'm not giving y'all credit anymore when you turn in just an answer. You're not going to get credit. I need to see your work. And looking at a lot of your work, it needs to be done on lined paper because your work looks like, some of you, unfortunately, it looks like an elementary school student did it. So do it on lined paper and do it neatly. All right, and it's going in the basket if you're in class. Or you're emailing a picture. If you're doing it e-learning style, you e-learners, when you're emailing this picture and the rest of the class is putting it in the basket at the end of the period, you should be emailing me a picture of your work at the end of the period, which is at 10:07. All right? I'm not going to accept late work from you guys at home anymore. Turn your work in when everybody else does, which is at the end of the period. So at 10:07, take a picture of what you got done and email it to me. And if you don't do that, you're going to get a 0, and I'm not going to accept late work. All right? These notes will be on. You should be in class right now. All right? You should be in a Zoom meeting right now doing this work. So if you're not, I'm sorry. I'm not going to accept all this late work. I'm tired of it. It's more work for me because you guys aren't doing your stuff on time, and I ain't doing it no more. So if you have a question, speak up now. Otherwise, I'm going to excuse you from this meeting to go do your practice problems.